All right, this is 11.2 out of the green book. So if we have two radicals and we multiply them together, we can put them under the same radical. So, for example, if I had radical 4 and radical 9, can we say radical 36? Yeah. And what's the square root of 4? And the square root of 9? And what's the square root of 36? Are those equivalent? So we can do it either way. We can multiply them under the radical and then find the square root, or we can take the square root, and then multiply them together. The same goes, if I have a number, I can break it down to other square roots. What factors make up 20? Yes?
4 and 5.
4 and 5. And we always want to look for a factor where there is a perfect square. So, in 4 and 5, 4 is a perfect square, right? Now, that means the square root of 4 times the square root of 5. Sorry. And what is the square root of 4? 2. And then I'm left with radical 5. Questions? Okay, so my answer is 2 radical 5. Now, had I chosen 10 and 2, it's going to be harder, but I can still do it. Okay, so we really want to kind of look for those factors that one is a perfect square at least. Yes, Andranik.
How would you do it?
What?
How would you do it?
I'll show you in a minute. I want to get you used to looking for those perfect squares. And if I were to get the square root of 20, plug it into my calculator, I get about 4.4. And when I multiply 2 times the square root of 5, which is 2.2, times 2, I also get about 4.2. Okay, so they're equivalent. Square root of 18. What are we going to break it down to? Kate? The square root of 9 and the square root of 2. So, the square root of 9 is what, Jack?
3.
And so what's my answer going to be?
3 rad 2.
3 rad 2. And you know what? I don't need to write both these steps. I would go with one of them. I think they're repetitive. Now, somebody said to me, my PowerPoint is saying, don't do 6 rad 3. But here's what I say. It doesn't matter what path you take. As long as you simplify all the radicals, it's fine to use. So one method of simplifying this is breaking them down into prime numbers. And 6, can we say that 6 is made up of 2 times radical 3? You guys with me? Does that equal radical 6? And then I've got that other radical 3. And radical 3 times radical 3 is what? And the square root of radical 9 is? 3. So do you see? Every time I have 2 of the same thing, I can pull 1 out as a perfect square. And I'm left with the square root of 2. Is that making sense? So, Andranik, does that answer your question? If I had, what was the number? So, square root of 20. If I broke it down to the square root of 10 times the square root of 2, I would have done 5 times 2 times 2. I can pull both of those out as a perfect square, and I'm left with 2 rad 5. Yeah.
What about it was rad 5, rad 3, and rad 2?
Can't do anything. It's already simplified. It's only a perfect square if there's 2 of them. So that's one method, but I think it's easy if you just start looking for those perfect squares, like 9 is in it, and go right to the square root of 9 is 3. I actually skipped this step. I skipped this one. I skipped this one right here. I just write it right away as radical 9 times radical 2, and then simplify underneath. Okay? Something like 35. What are the factors? Yep. 5 and 7 and 1 and 35. None of those are perfect squares, so it's already simplified. We stop there. Okay? I've already asked you to memorize your square roots to 400. Your perfect squares. All right, so number 1. How do I break it down? How about Audrey? And looking for a perfect square. Yes.
225.
Oh! Sorry, it was a sneeze. Square root, and it was recorded. Square root of 25 times the square root of 2. Okay, now what? Audrey, now what?
Rad 5.
5, not rad 5.
5. 5.
Rad 2. We keep it in the radical. 5 radical 2, or 5 rad 2, we can say. The square root of 25 has a perfect square of 5. So I want you to pause the recording and do number 2 through 6. Go. Okay, now let's check your answers. See, my PowerPoint does this in 2 steps. You can skip one of those. You don't need to do both. You can do this or this, not both. 27 is broken down how? Gabby?
9 and 3.
Good. I always write my perfect square first. So this simplifies to what?
3.
The bottom line, the whole thing.
3 to the and radical 3.
3 radical 3. Number 3, Gohar.
49 and 2.
Good.
And then you get 7 and 2.
7 what?
7 rad.
7 rad 2. Okay. Number 4, Leora.
4 and 3.
Good.
And you get 2 radical 3.
Perfect. 5, Ben.
9 and 5. And you get 3 radical 5.
Perfect. And number 6, Rachel.
7 and 4.
And what do you end up with?
You get 2 rad 7.
Good. Yes.
Number 3, I did 6 rad 3. No, 36 times 3.
36 times 3 equals what?
Oh, never mind.
Okay. 72. So when I break down 72, let's try it with 36 by 2. What's the square root of 36? And so I end up with 6 rad 2. Are you guys good with that? But what happens if I don't choose 36 and 2? What happens if I choose 8 and 9? Then we get what? 3 rad 8, right? Why are those numbers different? Gohar? Yes. 8 is not fully simplified. There's a perfect square there. So if you don't fully simplify, you will get marked down points. That hidden 4 is inside that 8. Right? So this really means 3 times 4 times 2. The square root of 4 is what? 2. So 3 times whatever this is, 2, times rad 2. 6 rad 2. Is that the same? So if you're sitting there doing homework with somebody and you do the same problem and you get a different answer, either somebody didn't simplify all the way or you did something wrong. But the rule is you have to simplify completely. Pull every perfect square out. Got it? I did have a girl last period. All she did was break everything down into prime factors. This is how she did it. It just came easier to her that way. So if she had 72, she just went 72 is made up of 2 times 36. 36 is made up of 2 times 18. 18 is made up of 2 times 9. And 9 is made up of 3 times 3. That's how she did it. And she said, oh, here's a perfect square to pull. And here's a perfect square to pull. And I'm left with 1 radical 2. 6 radical 2. So it doesn't matter which route you go. You have to pull your perfect squares out. Yes, Nicole?
How do you know which one to make a radical?
Well, look here. If I have this one and this one, once I pull it out of the perfect I take the square root, I lose the radical sign. So only ones that have not been pulled as a perfect square. So you will see like this one right here. Does that make sense? There's an extra 2 in there. All right. So now let's go on to, I want you to do 1, 4, and 6. Go. Pause the recording. 1, 4, and 6.
And 16.
You don't have to do it at 16 times 2.
Oh, I did it in 8 and 4.
Okay, so he's choosing to do equals radical 8 times radical 4.
And then I simplified 4 to 2 and 2.
2, and you had 8 was what? 4 and 2. And so then what?
And then you have to simplify that 4. Oh, you have to multiply when you break out the 4, you have to multiply that by 2.
Okay, so that's a 2. So it's 2 times radical 2. And it becomes
4 times radical 2.
4 rad 2. Okay? But do you see how simple it would be if I had done it by 16? 16 times rad 2. So that's 4 rad 2. Now, I keep hearing the question, do I have to simplify this 4? Nothing out of the radical gets simplified unless they're multiplied together by the next one. Okay, I asked you to do number 4. What can we say about 4? Yeah.
You said it was already simplified.
It is already simplified. The factors of 30 are only 1 and 15. 1, 30, 2, and 15. None of those are perfect squares. Oh, 5 and 6. Yeah, you're right. Okay. -5. Break down that 60 by 4 and 15. What's the square root of 4? 2. So I'm doing -5 times 2, radical 15. -10, rad 15. Questions? What's wrong, Nicole?
I'm still.
Okay, I'm going to go back and do number 6 a little slower. What is 60 made up of? I've got my -5. What's 60 made up of, Nicole?
30 and 2.
Huh?
30 and 2.
There's no perfect square in there, so can you think of one that
15 and 4.
4 times 15. Notice I put my perfect square first. I've got that -5 there. What's the square root of 4?
2.
So times 2, and then I've got my rad 15. Non-radicals get multiplied with non-radicals, -10, radicals with radicals. You clear, Nicole? Okay. All right. Now let's deal with some. Let's look at this one, number 12. Tell me about number 12. We don't say not factorable. We say, Jack? Yes? No real root. Remember, here's my real number system is rational and irrational. When the square root of a negative is an imaginary over here. So we would say no real root. Not a real number. Okay, now, variables. Break it up, numbers and variables. So the first thing I do is, how do I break up 18? Yeah.
9 and 2.
9.
9 next to the 15.
Hold on. No. Just the number. Don't.
Oh, 9 and 2.
9 times 2. Oh, let me do it right beneath. So I'm breaking up 18 to 9 times 2. And then I've got x to the 10th. What's the square root of 9? Yeah. And the square root of x to the 10th?
X to the 5th.
And I'm left with this rad. Is that how I write x to the 5th?
No.
Why? Because we have to put the absolute value because it is an odd result with nothing else left to multiply. Augie? So, is everybody understanding how I write that with the absolute value? Thumbs up yes, thumbs down no. Now, what about number 24, x to the 11th? Andronique?
You first factor out 24.
Well, we're not factoring anymore.
And
Break it down.
break them down.
2.
6 and 4.
And then how am I breaking down x to the 11th? Yes.
Is it x to the 5th?
No. Nicole?
Don't you take one x out?
And how do you write it?
X, rad,
No, x to the what power?
first.
Huh?
First? No, 5th.
No, you said 1x. So if I take 1x out of it, how many x's are left?
10.
Okay, so I'm asking you how to write it.
Oh, yeah.
Okay, of those, I'm going to just rearrange this a bit. Okay, what's the square root of 4? What's the square root of x to the 10th? X to the 10th. What? X to the 5th. But what's left that's not a perfect square is 6 and x. Now, why am I not writing absolute value this time? Yes.
Because the number's even.
No.
There's that x.
There's an additional x over here. Having this, okay, the only time I put the absolute value, if it's an odd result and there's no more x's to multiply it by. There's an additional x to multiply it by. So it's going to take care of the negative issue. Okay? Are you clear when to put absolute value and when not to? All right. Can I erase? Okay. So we always go like here to the closest even number underneath 11. 10. Do you understand? And then I can break it into a perfect square. Okay, let's look at this one. How would I break down the A? Okay, Kate? And A, times A. Right, so we're breaking them down. I don't know why it's not cool. Okay? And so when I'm doing a to the 30th, the square root of that is a to the 15th. And the square root of 4 is 2. I'm left with 10a. How about this one? Yes.
4 times 2. That's it.
Times.
Times y to the
Okay. And 4 is?
2.
And y to the 50th is?
Y to the 26.
And I'm left with that radical 2. Is that how I write it? Why, Jada? Pardon the pause. I just sneezed. Okay. All right. So, are you guys understanding why we have it like that? Now, let's look at this next one. It's kind of sneaky. Um, 32 gets broken down to 16 and 2. So it's 4 rad 2. How do we break down x to the third? Yeah.
X squared rad x.
X squared times x, all under the rad. And y to the 10th is easy. It doesn't need to be switched around. X squared times x. So I can pull perfect squares out of all these parts. 16 is a 4. X squared is going to be an x, and y to the 10th is going to be? Now, notice how my absolute value does not go around the x, but it does go around the y. Why is that? Nicole? There's still an x left in the radical. So I don't need to take care of my negative numbers there. Does that make sense? But there's no other y's. That's why it has to go. And it's an odd result. Now, you're going to get directions like this. Assume all variables are non-negative. When you get that, you get to throw the absolute value out the door and not even have to think about it. So on your quiz, I'll probably quiz you on some with absolute value, and then I'll start laying down the directions that say, assume all variables are non-negative. When I do that, you don't have to think about absolute value at all. Okay? You'll see they just simplify it. Even though there's b to the third, even though there's an a here, it's not an absolute value because I'm assuming there's no negatives. Okay. But you might be given something like this, where you have to factor, and it's a perfect square trinomial. Augie, how do I factor that? What does that become? David? Squared. Okay, hold on. Now, remember, if it doesn't say this, to the first power, I'm going to have to write the absolute value. But because it says this, I don't have to put it in absolute value. So hold on. Be careful. Shh. Freeze, please. Freeze. Look at this one. You have to factor out a 2 before you can factor the y squared minus 6y. So it's 2 times y minus 3 squared. The y minus 3 comes out, but the rad 2 stays under. Questions? All right.